All right, here's a good question application using exponents and logs. How long would it take for a population in a certain country to triple if its annual growth rate is 0.9%? And we assume that it stays at 0.9% for the whole time. Okay, so if we assume this exponential growth, then I can use this formula. Population after a specific time is equal to the population to start with, e to the k times t. Okay, now they say to triple. It's like they don't give us a starting and an ending number, but by saying tripling, they sort of do. Because you can start with any number you want, like say you're starting with 5 people. So if you triple that, it'll be 15. If you say you started with 50, if you triple, it'll be 150. Regardless, the ratio of that is 3. You're tripling. So you can use any number you want to start as long as what you end with is triple that amount. Okay, E, and then K would be your percent here, but that's 0.9%. If I change that to a decimal, it'll be 0. I got to move it over to 0.009. So that's my K, 0.009 times T. Okay, to solve, first thing I'll divide both sides by 50, and I'll get 3 on the left side is equal to e to the 0.009 t. And then I'll change this from exponential to log form. So log base e of 3 is equal to 0.009 t. Or log base e is the same thing as ln of 3. And then to solve for t, I'll divide both sides by 0.009. So let's get decimals out. So I want to go ln of 3, bracket, divide, 0.009. 122, and they say to round it to the nearest year. So the time would be 122 years. That'll take how long a population to triple if you're going up only by like almost 1% a year. Long time. Okay, next question. Bacterial culture has an initial population 10,000, so that'll be my P0. If its population declines to 5,000, so this would be my P of T, in 8 hours, I guess it's my P of 8. What will it be at the end of 10 hours? Let me write my formula. P of T equals P0e to the KT. So if I start with 10,000 and I end with 5,000, e to the, I don't know what K is. So I don't know that population decrease. So I don't know what K is, but I know it did that first decrease from 10 to 8 to 5,000 in 8 hours. So that's what my time is, 8. Okay, divide both sides by 10,000, so you get 0.5 equals e to the k times 8. Same game as before, change it to log form. So log base e of 0.5 is equal to k times 8. Ln of 0.5 divided by 8 should give me what k is. Okay, let me get decimals out again.
I got someone that personal message me and wanted to order 10 s'more boxes. That was on Sunday.
Okay. Let me get my decimals here working. Okay. So, I got to move that up a bit. Ln of 0.5. Ln of 0.5 bracket divided by 8. So I'm getting negative 0.08664. I like to use as many decimals there as I can in order to maintain accuracy. I think if you go into 5 or 6 decimal places, you should be okay. All right, so that K, and that's a percent. increase. In this case, it's a minus, so it's a percent decrease. But the question says, what will be the population at the end of 10 hours? Oh, so maybe I should use this formula again. P of t equals P0e to the k times t. So what will it be at the end of 10 hours? So that's the population after 10 hours. It starts with 10,000. E to the k is my number right there, negative 0.08664 times the time is 10 hours. Make sure when you do that on a calculator or something, probably a good idea to put these in brackets, just so that you're multiplying by 10 in the exponent and not down below. So let's try that. Okay, now, okay, 10,000 E, okay, where's my E? E, uh-oh, this thing's in my way. Okay, E to the bracket negative 0.08664 times 10 bracket. Let me look at that. Is that right? 10,000 e to the negative. Yep, good. So 4204, call it 4205. So the population after 10 hours will be 4205. Now let's just look at that and see if it makes sense. So in 8 hours it goes to 5,000. So in 10 hours it's got to be less than 5,000. So I'm getting 4205. That number makes sense. All right, so that's a question where you first have to find your growth constant or your decay or decrease constant. And once you find that, then you can use it over there. All right, hopefully that helps out.